Question 10, we've got some fractions to work with. So when we've got something outside the bracket as a power, then what you need to do is multiply the two things. So I'm going to do 3 times a half, and I'm going to just leave that as 3 over 2. I'm going to do the same with the other one, 2 times a quarter, which is 2 over 4. I can actually change that to 1 over 2 just by simplifying. So what I've now got is x to the power of 3 over 2 times x to the power of a half. Now what you do when you're multiplying powers is you add them. So 3 over 2 plus a half, or 3 halves plus 1 half is 4 halves, which is 2. So that leaves me with just x to the power of 2. For the next part, I've got to solve this. I've got a quadratic. So to solve a quadratic, the easiest way is to have it in double brackets with equals 0. Or you can use the formula, because it's a calculator paper, so it's alright to do that. But basically, either way, it's got to be equals 0. So the first thing that's wrong is this minus 18. But I can't bring it into the rest of the equation unless I expand this bracket. So the first job I'm going to do is x minus 1 and x plus 2. Then expand that, just like you do all your brackets. These two together make plus x plus 2, take away 1. And I've got that equals 18 from the start. I can subtract 18 from both sides. I get x squared plus x minus 20 is 0 now. So I can now solve it. Two methods. Easiest one is to be able to factorise it back again. I know I want x squared. I know I want minus 20. I want a pair of numbers that multiply to make minus 20, but add to make 1. So the pairs that make 20 are 10 and 2, 20 and 1, and 5 and 4. This one's got a difference of 1, so I know if I make it plus 5 and minus 4, that's going to multiply to give me 20, but work to give me the 1x in the middle. So my brackets are x plus 5 and x minus 4 equals 0. So the solutions are x equals minus 5 and x equals plus 4. Remember, it's opposites when you come out of the brackets. You could also use the quadratic formula and you'll get the same answer. So if you've got a pair of simultaneous equations, it means that there's one pair of y and one pair of x that matches for both equations. What you can do when it's a quadratic to make it easier to solve is replace y with what you've got for y here. So instead of y equals x squared minus 1, I'm going to have 5 minus x equals x squared minus 1. I'm going to try and solve it just like I did the one before, so I'm going to need to get it to be x squared equals 0. I'm going to add this x. I get 5 is x squared plus x minus 1, and I'm going to subtract 5. So I get 0 is x squared plus x minus 6, which is what I want. Again, it's nice because I can look at this and go, numbers that make 6 are 6 and 1 and 3 and 2. This has a difference of 1. So I know that if I do x plus 3 and x minus 2, 3 times minus 2 is minus 6, but plus 3 take away 2 is 1. So if I set that to be equal to 0, then I know my solutions are x equals minus 3 and x equals plus 2. Opposites again, because 3 take away 3 is nothing, and 2 take away 2 is nothing. If those are the x values, then I've got to go back and work out the y values. Y is equal to 5 minus x, so if it's minus 3, it's 5 minus minus 3. This, 2 minuses become 8 plus, so that's 8. This one, y equals 5 minus x, so y equals 5 minus just 2 in this case, so y is 3. So my two pairs, the reason they've given you two lines is you've got x equals minus 3, y equals 8, and x equals 2, and y equals 3. Okay, next question is cumulative frequency. We're not having to draw it, that's already done. It says write down the number of people who waited for 20 minutes or less. So we're simply going to look for 20 people on cumulative frequency, go along and down. That reads as 12, 14, 16 people. The next one, work out an estimate of the number of people who waited between 26 and 40 minutes. So we're looking at minutes this time.